In this video here, we're going to take a look at dynamics and inclined planes. So when a particle is moving along a rough plane, the force of friction is equal to μr, and it acts as to oppose the direction of motion. And this is a concept that you should be very much familiar with by now. So this video builds on everything that we have covered so far for applications of forces. So just make sure then that you have watched the previous videos within this chapter on applications of forces. And then finally here, you do also need to be familiar with the Suva equations of motion from the first year applied material before continuing with this video. But other than that, we don't need too much more here for dynamics and inclined planes, so let's just work through one practice question together. So let's just have a go then at this practice question here. So for this question, we're told that a particle is held at rest on a rough plane which is inclined at an angle of alpha to the horizontal. The coefficient of friction between the particle and the plane is 0.4. The particle is released and slides down the plane. We're then given that tan alpha is equal to 3/4, and then the question wants us to find a couple of different things here. Now before we begin then with part A here, it's quite glaring, right, that we don't have a diagram for this question. And to answer questions such as this one here, a diagram really is essential, right? If you try and answer this question here without a diagram, I promise you, it's not going to be much fun. So to begin with then, let's just start here by drawing our own diagram. So what I've got here then is the horizontal. We then have the inclined plane, like so. And we also have our particle here, okay? Like so. We also have the angle of inclination here, which is given as alpha, like so. And what we also need to include here then is the relevant forces. Now for this question here then, you might have noticed as we read through the question that the mass of the particle wasn't stated. So in that case then, we just take the mass here to be m, okay? So what that means then is the weight here of the particle acting vertically downwards will just be mg here, okay? And don't forget as well that we also need to split this force here, the weight, up into components. So if we do that here, what we obtain then is a right angle triangle. So for this component here, this will be mg cos alpha. So mg cos alpha. And then for this component here, this will be mg sine alpha. So mg sine alpha there. Okay. Like so. So what other forces do we have here? Well, we also have a normal reaction here then between the particle and the plane. And we'll just label that as R then. So that's our normal reaction here. We're also told that the particle is released and slides down the plane. So what that tells us then is the particle here is accelerating down the plane. So it's accelerating down the plane then. And in that case, friction here opposes motion. So friction is acting up the plane. So that's μr there. Okay. And I think at this point here then, we now have a relevant diagram to answer part A and part B. So for part A then, all we want to do here is find the acceleration of the particle. So for part A then, let's just begin by resolving perpendicular to the plane or the acceleration, whichever way you prefer to think of that. Okay? So we're resolving perpendicular to the plane, taking upwards as positive. And for the first part of this question, then part A, we do also need to use F equals ma here because we are accounting for acceleration. So to start us off then, what forces are acting upwards here, perpendicular to the plane? Well, in this case here, we just have the single force of R. So we have R. We now consider what forces are acting downwards, perpendicular to the plane, which is just this single force here of mg cos alpha. So we obtain R minus mg cos alpha, like so. And this here then is equal to the mass times the acceleration. So the mass here, as we already know, it is just m. And we then times this by the acceleration, which in this case here, considering a perpendicular sense, is just 0, right? Because the particle is accelerating down the plane here. So we have m times 0 there. like so. Well, clearly then, my right-hand side here is just 0. And in that case then, R is equal to mg cos alpha. Okay. Now, before we continue here, let's just quickly note then that tan alpha is equal to 3/4. Well, why is that relevant? If I just quickly draw a right angle triangle here, something like this, with this angle here being alpha, if tan alpha is equal to 3/4, what that tells me then is the opposite here is 3 and the adjacent is 4. Okay? And by basic Pythagoras here then, hypotenuse must be 5. And in that case then, we can obtain that cos alpha. So cos alpha here. This is the adjacent, that's 4, over the hypotenuse, which is 5. And then in a similar fashion here, sine alpha is equal to 3/5. Okay. So if r is equal to mg cos alpha here, what we have then is r is equal to 4/5 of mg, or 0.8 mg, whichever you prefer. Okay, so we'll write that as 0.8 mg there. Okay, and let's call this equation here then equation 1. So now what we're going to do here is resolve parallel to the plane or the acceleration, again, whichever way you prefer to think of that. So now let's resolve parallel to the plane here, taking down the plane as positive then, like so. And again, we do also need to use F equals ma here. So what force is acting down the plane, parallel to the plane as well? In this case, just this force here of mg sine alpha. We get mg sine alpha, like so. There's no more forces acting down the plane here. So we now consider what forces are acting up the plane, which in this case here is just friction, right? We obtain minus mu r there, like so. And this is equal to the mass times the acceleration. So in this case here, the mass is m, and the acceleration is just a. So we obtain ma there. Okay, and let's call this equation here equation 2. So what I'm now going to do here is substitute equation 1 into equation 2. So what we obtain here then is mg. So mg sine alpha minus mu r here. So minus mu, which don't forget then, mu here is 0.4. So minus 0.4 r, where r is equal to 0.8 mg. So minus 0.4 times 0.8 mg. And this here then is equal to ma. Like so there. So what we can do here then is divide through by m. So these m's here will just go like so. And if we now simplify them, what I've got here is sine alpha times g. Well, sine alpha is 3/5. So what I've got then is 0.6g here. So 0.6g minus 0.4 times 0.8g. So that is minus 0.32g there. So minus 0.32g. And this is equal to a. So if we simplify the left-hand side here then, what we obtain is that the acceleration a is equal to 0.28g. And at this point here then, just use your calculator, right? So we do 0.28. I'll do this as well because I haven't done it already. So 0.28 times 9.8. What we get here then is 2.744. So if we round this to, say, two significant figures here, given that we took g as 9.8, in that case, then the acceleration here is 2.7. So 2.7 meters per second squared there. Okay. And there we have it then. So that gives us the solution to part A. So now for part B then, let's do that over here. We now want to find the distance that the particle slides in the first 2 seconds. So to answer part B, we now need to use the trusty old Suvat equations. So let's just make a note here then. So now use Suvat equations. Okay. So to begin with here, what do we know? Well, the particle is held at rest, right? Where we're told that. We're told that here. The particle is held at rest. So what that tells us then is u, initial velocity, is 0. We know the acceleration, that is 0.28 g here. So a is equal to 0.28 g. And we'll keep it exact for now. And we also know t. So t here is 2, the first 2 seconds. Okay, so t is equal to 2. And what do we want to find then? We want to find s here. Okay, we want to find what s is. So in that case then, based on what we have to hand here, we're going to use the following Suva equation. So we're going to use then, so use s equals ut plus a half at squared. Okay? So, putting all of this together here then, what we obtain is that s is equal to ut, so that's 0 times by t here, so 0 times by 2, plus a half times by a, which is 0.28 g, so 0.28 g, and then we times this by t squared. So t here is 2, we times it by 2 squared, which is obviously just 4, like so. So, again, all we need to do here, right, is just use our calculator. So what I've got then is 4 times by a half, which is 2. So 2 times 0.28 times 9.8. So what we get here then is 5.488. And again, let's just round this here to 2 significant figures. So in that case then, s is equal to 5.5. So 5.5 to 2 significant figures. So 2 significant figures. And in that case then, what we can say here is the particle. So the particle here slides. So it slides 5.5 meters here. So 5.5 meters down the plane. Okay, so down the plane here. And there we have it. So just to finish with, just a quick conclusion there, that the particle slides 5.5 meters down the plane. Okay. And there we have it then. So that gives us the solution to part B. And that gives us the solution then to the one practice question for this video here. And that brings us to the end then of this video here on dynamics and inclined planes.